and the range would be the second set.
Life hates me.
Aw. Here, your math teacher does know. There you go. So, a relation is just where we have a set of ordered pairs, where there's some relationship. And it doesn't always even have to be ordered pairs. We can have different types of relations. But given this relation, find the domain. So the domain would be the first set of ordered pairs. What would it be, guys? 3, 1, and negative 2. Now, a lot of times we will list the domain in increasing order. So we would start with our lowest term and work our way up. The element. The range is the second set of ordered pairs. So it's 2, 6, 0. Any questions? All right. What would this be? This is a really bad joke, actually. And it's not even mine. This was one of those teacher share sites. It's a bad relationship. That's terrible. All right, so here's our relation. 2, 1, negative 1, 3, 0, 4. And it can be illustrated several different ways. Here we have it illustrated as a table. So we can take that relation and display that information in a table. This is a mapping. Now usually our mappings have arrows to show us our input versus our output. So they would have arrows here. Or we could have a graph. So given this table, show the relation. And they're talking about a relation written as a set of ordered pairs. So if we wrote it as a set of ordered pairs, we would have the negative 1 paired with a 3, the 0 paired with a 6, the 4 paired with a negative 1, and the 7 paired with a 3. So here we're taking a table and writing it as a set of ordered pairs. And we know it's a set because it's included with the braces at either end. All right, our domain would be the negative 1, 0, 4, and 7. And our range would be the 3, the 6, and the negative 1. Now we don't have to list the 3 again because it's already listed in the range, isn't it? Okay, here's that same information as a mapping. The negative 1 is paired with the 3, the 0 with the 6, the 4 with the negative 1, and the 7 with the 3. So there's the relation as a mapping. And once again, you don't need to write the 3 twice in the range. All right, so here is our relation. What is the domain? Put your hand up with the numbers. Do you think it's 1? Do you think it's 2? Do you think it's 3? Do you think it's 4? Do you think it's 5? I want to see everybody's hand up with what they think it is. Okay, it is 3. Do you know in Italy they do 3 like this? And if you go to a store and you're like 3 like this and they see this finger raised, how many of whatever you just asked for are they going to give you? 4. Yes, they will. Yes, they will.
Every day.
You would not list them again. No. Each thing is listed only once. All right? Okay. Great. Let's do it again. I want to see what you think. Is it 1? Is it 2? Is it 3? Is it 4? Is it 5? This time we're looking at the range. What do you think? I agree with C. I would say 4. The
Wait, no,
range
it's this. It's this.
1, 2, and 3.
Mine's the Italian version.
Mine too.
What?
I said I'm doing it the Italian way.
Me too.
The Italian way would be like, I can't do it.
Oh no, I was just doing just.
Well, you said if we did this in the store, they'd give us 4.
You're right. You're right. Y'all got me, didn't you? All right. So here we go. Now, a very special type of function relation is called a function. And what defines a function from just any other relation is that each of those elements in that first set, called the domain, is paired with exactly 1 element of the range. In the domain, it can only be paired with exactly 1 element of the range to be considered a function. So when we look at this, x is our domain, our input. We put it into the function and we get out the output, our y. So when we have function notation, and we'll talk about this in a minute, y equals f of x, Did some of you start using function notation last year?
We did last year.
A little bit? Okay. Y is going to represent our output, X is going to represent our input, and F is the name of the function. So this is Y equals F of X. But we can name functions differently just like we name people, so that I can identify who you are. You were given a name, right? Well, I can name functions. We could have F of X and G of X and H of X. And it doesn't even have to be of X. We could have C of T. We could have name our functions lots of different ways. So this particular function is named F, the function F. All right, determine whether the relation is a function. So let's look at this. The 2 in our first ordered pair in this set is paired with 3. And then we have a 3 paired with only one number, 0. And then we have this input 5 only paired with one number, 2. And then we have 4 paired with 3. Are there any numbers over here that's paired with more than one output? No. Each input is paired with exactly one output. So yes, this is a function because each input is paired with exactly one output.
Or can you give us an example where it's not?
Yes.
Okay.
Maybe like right now.
Okay.
Okay, so let's look at this one. The 4 is paired with 1. The 5 is paired with a 2. The 5 is paired with a
3.
3. The 6 is paired with 6, and the 1 is paired with 9. Now, this is not a function because I have this single input, 5, paired with 2, and paired with 3. So no, it is not a function because there is an element of the domain that is paired with more than one element of the range. Does that make sense? Okay, now we're going to work on how we explain it. That is why some of you may have been taught a trick last year. Were any of you taught a trick to look to see if the x's repeat? Yeah.
Miss Benefield.
Yeah, that is a trick. And I tell my students, that's what we look for. Do the x's repeat? But that is never the reason why it's not a function. We have to go by the definition of a function. And the definition of a function says each input is paired with exactly one output. So we can't say the x's repeat. What we have to say is that one element of the domain, in particular 5, is paired with more than one element of the range. But if we just look up here, you see the 5 and you see the 5 and they're paired with 2 different things, done. So if you're just doing yes or no's, you can look to see if the 5 repeats or if a number repeats. But whenever you have to explain, you have to know why. And it has to be because of the definition. Is this relation a function?
Yes.
Yes. It is. Each input is paired with only one output. Now, all the outputs are the same. Is that okay?
Yeah.
Yes, it is.
Wait, so I have a question.
Okay.
Since all the outputs were the same, if there was a repeating input, it would still be a function, correct?
It would be because you would have listed a single point twice.
Right. Okay.
So it's really not a new point. You just it would have accidentally been listed twice.
Okay.
Alright, vertical line test. Now if we have a graph, how can we tell if we have a function? If any vertical line passes through more than one point of the graph, then that relation is not a function. Because that means for one input x, there are more than one outputs. Are these functions? If I drew a vertical line anywhere on the graph, let's see what it would look like. Okay, there's a whole bunch of vertical lines. Did any of these vertical lines pass through more than one point?
No.
No. Is it a function?
Yes.
Yes, it is. Okay. Here is, does anybody know what the special name of this one? It's a parabola. It's a quadratic function. You'll study those next year. Okay. There's the vertical lines. Do any of them pass through more than one point?
No.
No. Is it a function?
Yes.
Yes, it is. Okay. This is the conic, a circle. Is it a function?
No.
No. Because if I give you this input here at 0, do you see there are two outputs? 0, 0, and 0, 6. Got it? So no. All right. One for you to try. What do you think? Is it a function? Yes or no?
Yes.
Yes, it is. Is it a function? No, because if we drew a vertical line on top of that line, there are infinite number of points. So for one input, we have an infinite number of outputs. So an x equals line is not a function, but a y equals line is a function. Because this is y equals, is that 2? And this is x equals 2. Okay, yes or no? No. No. This is the parabola that opens sideways. No. Alright, yes or no?
Yes.
Yes. This is a cubic function. And the answer is yes, it is a function. Okay, that's where we're going to stop with the PowerPoint today. We're going to pick up with your explorations workbook now. Okay, open your workbook to page 156. This one. This is one of those hitting pencils. Okay. So, the domain is our input. The domain is our input on the function. And it's generally represented by x. Not always, but generally. The range is our output, and it's generally represented by y, or f of x. So here we have a mapping. Does this mapping represent a function?
Yes.
Yes, it does. Each element of the input only has one arrow coming out of it. Each one is only paired with one element of the output. So a function can be described using function notation. The function f assigns the output value, f of x, in the range to the corresponding input value, x, from the domain. And we read this, the notation f of x is read f of x. This does not mean f times x. That x being in parentheses right there does not mean times. We read it f of x. For the function shown above, f of 3, for input value 3, it equals 9. The output value is 9. Does that make sense? What would f of 4 be? 16. Alright, I know some of you are staring at this going, I know the rule. I know what's going on. What do you do to your input to get your output?
Multiply by 2. No, you just
Square it.
Yeah.
All the time.
Thanks, Abby. You swear it. So the way we would write that is, for this particular function, square the input to get the output. Does that make sense? Okay, did you catch that?
Yes, ma'am.
Good. Alright, let's take a look at the bottom of the page, and we're going to work on some of these. The domain of the function can be written using set notation, and that's how we're going to write it, using set notation. Now, do you see how it begins and ends with the braces? Now, some of you are going to tell me I can't draw that. Okay, a brace looks like this. If you can't draw that, then you scribble over here and you scribble over there. And I'll consider that a brace. Okay, so I would like you to go and now write the range of that function.
Is this in our workbook?
Yes, we're on page 156.
155.
155.
Okay, I'll go there. Yep, found it.
Sorry,
It's okay.
I had fixed it and then I did not save what I fixed. Oops. Okay, did you get 0, 1, 4, 9, 16?
Yeah,
And that is our range. Okay, tell how to read this statement. Who would like to read that for me? Okay, Shelby?
F of 4 equals 16.
F of 4 equals 16. Matt, would you like to tell me what that means?
Oh.
I didn't know.
We
Sorry.
both have the
I
same
need it.
name.
Matt Horn.
Okay. Function of 4. No, wait. F of 4 is equal to 16.
F of 4 is equal to 16. So, when your input is 4, how would you finish that statement? Your output is 16. Good. Good. Okay, so F of 4 equals 16 when the input is 4, the output is 16. Okay, now this is going to change some stuff to what we're looking at. This says suppose the 3 were paired with 4 instead of 9. So let me go back and make that change for us.
No.
So the 3 is no longer paired with a 9, so I'm just going to white that out. Okay? I got whited out. Whoa! There we go. Sorry. Big dot. That is funny. You don't want to measure anything? Bye-bye.
I wish I had one of those for my summer work, actually.
That would have been cool, wouldn't it? Okay, so I got the 3 paired with the 4 now. Is it still a function?
Yes.
No.
No. Yes.
Is each element of the input paired with only one element of the output?
Yes.
Yes, it is. There's only one arrow coming out of each one. So is it still a function?
Yes.
It is, because each element of the input of your domain, each element of your domain is paired with only one element of the range. So yes. Each element of the domain is paired with exactly one element of the range. Okay, now suppose the 3 were paired with a 4 and a 9. Okay, so it's an Eller domain is paired with more than one element of the range. Okay, no, you didn't have to say it like that. You could say one input is paired with two outputs. Couldn't you?
Yes.
Yeah. Alright, 1E. If you pair the month, so January through December, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, with the possible number of days in the month, will you get a function? Think about it for a second before you shout out. If you pair the number of the month with the number of days in the month, will that be a function? I heard a no. Who would like to claim that no? All right, Roland.
I know.
Why do you think it's no?
Because the input is paired, which the months is paired with the days, which is the output, but there's more than one amount of days.
For which month?
For, well, like, so, because, well, yeah, I know.
Okay,
Never mind,
Spencer?
I want to say yes.
Yes.
You think yes?
But I can't explain.
Yeah, no, I can't even explain.
Because
I just think
well,
it's
the months, there's 12 months.
Uh-huh.
So none of those months, 1 through 12, repeat
Okay.
for the domains.
Okay. All right. I like your reasoning. All right. Share with me.
Oh, it's not a function because each month only paired
No,
with
it's makes it different.
Okay. Because we could come up here and we could all split and choose sides, and y'all could have like a real one.
Dude, don't do that.
Can we really do that? I can put money on
No, we wouldn't really do that.
I would do it though.
Okay. I'm
I'll
sorry.
win.
All right. Hold on. Matt Corrigan was speaking to us. You can finish.
Because one input is paired with multiple outputs.
Which one?
For each month, there's multiple that are paired.
Okay. Sabrina, what are you thinking?
Well, I was thinking the same thing as Matt, but I was just gonna word it like, so January's gonna have 1 through, I don't know, because there's 30 or 31 days in January. It's just gonna be like 1 and 2 and 3 and 4, like all the way up.
I think what this is saying
Unless
is
it's
not the
worded.
individual days, but the possible number of days.
Oh.
So January has how many days? 30. 1.
31.
Y'all know the knuckle thing, right? The ones on your knuckles have 31. The ones in the phallies don't.
Except
So
for
January has 31. February does not. March has 31. April does not. May has 31.
So it's every
Does
other
not.
month.
July has 31.
Nope.
Yes, come back around. August also has 31. And then September does not. Now, all the days are 30 except for what month?
February.
What's wrong with February, and why does February keep us from being a
That's the
function?
leap month.
Different from a
It
leap.
can have 28 or 29 days.
So I was right.
So, you were right, but,
I was right
no doesn't get us. We have to know why.
Dude, look out.
We have to know why. So this is no. It is not a function. Because February can have 28 or 29 days. Therefore, do y'all know the symbol for therefore? Do y'all know the 3 dots that form a triangle mean therefore?
Never knew that.
And, okay, there you go. That'll help you when you're taking notes. In case you need to use the word therefore often while taking notes. Therefore, it is not a function. Would be a little bit fun. Because one input is paired with 2 outputs. is paired with more than one output. Okay, so that was a thinker. Output should be one word. Sorry. Alright. Now, this is a tie into science, so we're on page 156 finally. Sorry for those of you who were there earlier when I told you to go there. Functions can be used to describe a relationship between two variables. Now, in science you call one of the variables the independent variable, right? The independent variable is our input for our domain. And the dependent variable is our output, therefore our range. So the independent variable is your x, usually. The dependent variable is f of x, what you get at, your y. Any questions about that? Okay. Now, we may do some of these. I'm not going to write them, but tell me. Tell whether or not the pairing of numbers describes a function. If each whole number from 0 to 9 is paired with its opposite, does that give us a function?
Yes.
Yes. And our domain would be 0, 3, 4, 5, 6, 7, 8, 9. And what would our range be? Negative. Okay, so -9, -8, -7, -6, -5, -4, -3, -2, -1, and 0. When we do the opposite of 0, don't we still get 0? Okay, good. Alright, number 3, skip to whole numbers, 10 to 12, paired with their factors. So, if I did a mapping, we'll let this be my input, 10. What are the factors of 10?
2.
2,
1.
5, 1,
10.
10. Okay, so we get 10 paired with 2, 10 paired with 5, 10 paired with 1, 10 paired with 10. Is it a function?
No.
No. Because right off the bat, we have one input paired with 4 outputs. More than one, not a function. Okay, number 4. Even numbers from 2 to 10 paired with half the number. So even numbers give me 2, 4, 6, 8, 10. And half would be 1. Let's get rid of that. 1, 2, 3, 4, 5. So they're paired this way. Is it a function? Yes. Okay, number 5. Function or not? No, we got a problem here. 36 is paired with 6, and 36 is paired with -6. We got a problem here. We got a problem here. Okay, it was nothing but problems. Okay? Each element of the domain is paired with 2 elements of the range. Not a function. It can be at most 1. Any questions? Okay. Flip over to page 161 now. And we're going to look at the different ways we could write this. So here we're given a relation. Is this relation a function? They didn't ask us that, but I'm asking you. Is it? Yes, it is. Okay, we're going to take this set of ordered pairs, write it as a table. So here we go. -5 is paired with 3. -2 is paired with 1. 1 is paired with -1, and 4 is paired with 3. Okay, as a graph, we're just going to plot the points. -5, 3. -2, 1. 1, -1. 4, -3. Does this pass the vertical line test? Yes. If we say yes, it's a function here, when we graph it, it better pass the vertical line test. Okay, mapping. -5, -2, 1, 4, with 3, 1, -1, and -3. So it should be mapped where the input is mapped to the output. Does that make sense? All right. I would like you to do number 3. And number 5, you're asked to write the domain and the range. So write it as a set. Write the function. And then explain. You know what? You don't have to write the explanation, but be ready to say it out loud.
What do we not have to write?
You don't have to write the explanation. So be ready to say it.
Is this the homework?
It's part of the homework. Okay, so for number D, did you get -3, -2, -1, and 0? And then we got 12, 13, 14, and 15. Okay, Michaela, function or not?
No.
No! Hey, Don, tell me why it's not.
Because the element in the input is matched with more than one of the output.
You are so right. -2 is paired with 13 and 15. Very good. I like the way you said it. Okay, number 5. Our domain is 0, 2, 4, 6, 8. 8. And for the range, did you just list them once? So you had 4, 6, and 8. We only list them once. So 4, 6, and 8. Okay, Evan, function or not?
No, because the input, no, yeah, I think it's input. Input is paired with more than one output. No, I think I got the words mixed up.
No, you got the words right. You got the yes and no part mixed up. So you're right. Each input is only paired with one output, so it would be.
Oh, my bad. I was looking at the range.
You went here?
Yeah.
Okay. So this one is yes. Each input is paired with exactly one output.
That's what I was paired.
Alright. So now I want to go back to number 4. Because number 4 is special. The way we write the domain and range. Now, these are discrete numbers. And this is a continuous graph, isn't it? It is continuous. This line means it includes every point from here to here. So it includes from 0, there might be like a 0.333. There may be like 1.76, 2 3/3. 2 3/3, that's funny. 2 2/3. All those points are included in that line. All those x values. So when we look at this, for the domain of this graph, it's all the x values from here to here. So what are the x values here where it starts?
0.
0. And what are the x values here where it ends?
3.
3. There are 2, and go ahead and put dots at the end of this. Close dots. I think they're intended to be there. I just don't see them. So this domain goes goes, it's all the x values between 0 and 3. And some of you may have written it as a compound inequality last year. Did any of you write it that way?
Yes.
Okay, so this is all the x values between 0 and 3. Now, I want you to understand the compound inequality. But what we're going to start using is something called interval notation, where we give the interval over which this holds true. Oh, I'm on notation. Interval notation. There we go. All right. So what we would do on interval notation, we would use the parentheses and the brackets. We use brackets if it includes a value. We use parentheses when it does not include a value. And we're going to do some of both. So I made you put dots at either end. So it's going to include this value here and include that value there. So we would show the interval, and it always goes least to greatest. Okay, so it would go from 0 and include the 0 because we have the closed dot all the way to 3. And this is the interval for our domain. The x values go from 0 to 3. Does that make sense? All right, now let's do the range. So the range is our y values. And do you see they go from 1 up to 4? Our y values go from 1 to 4. So written as an interval, it would go from 1 to 4. If we wrote it as an inequality, it would be 1 is less than or equal to y is less than or equal to 4. Now, because you guys are all on the track to apply for an AP Calculus class, you're all hopefully headed to an AP Calculus class one day, we're teaching interval notation. It's very appropriate for the track you're on. But on the end of course test, we will probably see domain and range written as with inequalities. So I want you to see them. I want you to know what they mean. Be familiar with them. But what we'll use mainly is interval notation. So in your quizzes, I may say, or give you a multiple choice where it's not here, it's the inequalities. Just to make sure we don't forget what that means. Okay, let's take out that little sheet I gave you. And the first, we're going to do 2 of these problems together. Now, is number 8 a function that pass the vertical line test?
Yes.
Yes, it is a function. It does pass the vertical line test. Now, let's do the domain and the range. Do you see this one is going left? Oh, once you add the arrows, you can see it is going left forever. Going forever in this negative direction. Anybody know what we use to represent forever in a negative direction? We are going to use infinity, but because it's in a negative direction, we're going to use negative infinity. What's forever in a positive direction? Positive infinity. So when we think about our x-axis, this is negative infinity, forever in the negative direction. Forever right is positive infinity. So for this one, the domain is going forever left. So the least value is negative infinity. Now, can we actually get to negative infinity? No, it's not a number. We can't get there. It's an idea. It's a concept. So since we can't get there, can we ever include it? No. So with infinity, we're always going to use the parentheses. And this one goes right forever, so that would go to positive infinity. Does that make sense? All right, now let's look at our range. Our range is going to be our up and down. Do you see this one goes down forever, down forever, down forever, but it has a top point, doesn't it? So, since it goes down forever, what describes down forever? Negative infinity. to what is this top point right here?
Positive 4.
Positive 4. So if we were to write the range, the range is going to be our least value, negative infinity, to 4. Does it include that 4? Yeah, it actually gets right up to it. So we include the 4. Okay.
Wait, and why would we do the brackets on the right side again?
It includes the 4. It gets to 4 right there. There's a 4 right there. All right, now let's look at this one. Does it pass the vertical line test? Yes. Okay, and it looks like it has x values from about here to here. This looks like the smallest x and the biggest x, doesn't it? So how would I describe the domain of this one? What is this point right here about? Negative 5. And what is this point over here? 10? Is that what it is? Yeah. Yeah. So this goes from about negative 5 to 10. There we go. Now, does it include the negative 5? What does that open circle mean? It does not. Does it include the 10? It does. If we wrote this as an inequality, it would be negative 5 is less than x is less than or equal to 10. All right, bottom to top. There's the lowest value. Whoops, wrong color. Highest. So what would the range be? Lowest is negative 8 to highest, positive 8. Does it include those numbers? Yes, it does. Okay, questions about that?
When you said, like, in this case, is the interval thing, and you said what parentheses and brackets meant,
Mm-hmm.
can you tell me what each of those mean? Oh,
Parentheses do not include. They do not include the point. Brackets include the point. All right. Now I want you to flip over in your book to page 198. And we're going to talk about a particular function that you actually studied last year, the linear function. We have been doing linear equations for a while, haven't we? And a linear function is represented by y equals mx plus b. But if we're talking about it in terms of a function, is it fair to say f of x equals mx plus b? Yeah, sure it is. Well, m represents the slope, and b represents that y-intercept. And when we have a linear function, this slope, no matter which 2 points I pick on that line, the slope between those 2 points is always the same. I could pick an infinite number of points and calculate the slope on a line, and I'll always get the same answer, won't I? Because the slope on a line, that rate of change, is constant. Our slope is constant. And you could say it has a common difference. So I'm going to give us a little table here. And we'll do 0, 1, 2, 3. And we'll say 5, 7, 9, 11. Now, you guys know how to actually calculate slope, right? Slope is just the change in the y's over the change in the x's. Does everybody know that the delta symbol means change? Okay, good. You do now. Change. So you may have, some of you may have written delta y over delta x, or some of you may have just learned y2 minus y1 over x2 minus x1. So do we see that x's are changing by 1? Does everybody see that? And what are the y's changing by? 2. So for each equal increase in my x, do you see I get an equal increase in my output? Do you see that this is constant? So this is a linear function, isn't it? And my slope of this linear function is 2, because 2 over 1, 2 over 1, 2 over 1. The difference in your y's over the difference in your x's, the difference in your y's over the difference in your x's, the difference in your y's over the difference in your x's. Did it remain the same? Yeah, it was a constant 2. And the y-intercept is? Well, the 0, y is 5. So this is a linear function, and we could write it that way. Okay? Now, we don't even have to have a constant increase in our x's. I could do like 2, 4, 6, 8, and 3, 6, 9, 12. Do you see that this is constant change of 2? And here I get 3, here I get 3, here I get 3. So my slope is 3 halves, 3 halves, 3 halves. Is that a line? Alright. Please write down the homework before you leave, because I've taken off a lot of the problems off the calendar. It's the worksheet plus page 197, just numbers 15, 17 through 22, and 24. So it's the worksheet, and then page 197,